Hello, and welcome to tonight's Space Sleep story. If you appreciate what we do here, please like or subscribe for future relaxing nighttime space journeys. Tonight we embark on a journey through one of NASA's most remarkable missions. The Messenger spacecraft, humanity's first messenger to orbit Mercury. So settle into your most comfortable position, close your eyes, and prepare to witness a decade of dedication, precision, and discovery. Before we begin, let us prepare your body and mind with gentle breathing. Take a slow, deep breath with me now. Inhale gently for 4 counts. Hold the peace. Exhale for 6. Feel your body releasing into stillness. Let the tensions of the day drift away, like spacecraft leaving Earth's atmosphere. Breathing in calm, breathing out worry. Another gentle breath as we continue our preparation. This time, notice how your chest rises and falls, like the patient rhythm of orbital mechanics. Breathe in for 4. Hold this peaceful moment. Exhale slowly for 6 counts. Feel the stress leaving your body with each breath. With each breath, you release a little more into relaxation, preparing for our journey to the innermost planet. Mercury remained largely mysterious throughout the 20th century. Mariner 10 flew past 3 times in 1974 and 1975, photographing only 45% of the surface. For the next 33 years, scientists could only wonder what secrets the remaining 55% held. Throughout the 1990s, planetary scientists advocated for a return mission. They needed to answer fundamental questions about this enigmatic world closest to the Sun. On July 7, 1999, NASA selected Messenger as the 7th Discovery-class mission. The name means Mercury surface, space environment, geochemistry, and ranging. A perfect acronym connecting to Mercury's mythological role as the messenger of the gods. Dr. Sean Solomon from the Carnegie Institution became principal investigator. The Applied Physics Laboratory at Johns Hopkins University would design, build, and operate the spacecraft. A decade-long journey was about to begin. The spacecraft itself represented engineering excellence, compressed into precise dimensions. Messenger measured 1.85 meters tall and 1.27 meters wide. At launch, it weighed 1,107 kilograms, including 607 kilograms of propellant. 2 solar arrays would span 6.1 meters tip to tip when deployed, generating 450 to 700 watts of power. Every component designed for the harsh environment near the Sun. The thermal challenge was extraordinary. Mercury receives solar intensity 11 times stronger than Earth experiences. Ralph McNutt, project scientist, described it perfectly. Mercury is punishing. We had to build a spacecraft that could survive inside an oven. The solution was a sunshade measuring 2.5 meters by 1.82 meters, made of ceramic fabric originally designed for industrial furnaces. This shield would protect instruments from temperatures exceeding 300 degrees Celsius. Seven scientific instruments totaled 50 kilograms of payload. The Mercury dual imaging system would capture surface photographs. A gamma-ray and neutron spectrometer would analyze elemental composition. An X-ray spectrometer would study surface minerals. A magnetometer would map Mercury's magnetic field. A laser altimeter would measure topography. An atmospheric and surface composition spectrometer would analyze the tenuous exosphere. And an energetic particle and plasma spectrometer would study the space environment. Each instrument precisely calibrated for discovery. Communication required redundancy and reliability across vast distances. A high-gain antenna, measuring 1.5 meters in diameter, would transmit science data to Earth. Two low-gain antennas provided backup contact during emergencies or off-nominal orientations. The propulsion system featured dual-mode capability, a bipropellant main thruster generating 660 newtons of thrust and 17 small thrusters for precise attitude control. Every system designed for the 6-year journey ahead. Reaching Mercury presents a counterintuitive challenge. Despite being Earth's second closest planetary neighbor, getting there requires extraordinary precision. Andrew Calloway, Mission Operations Manager, explained, "Mercury is actually very hard to get to because you have to lose tremendous orbital energy. A spacecraft leaving Earth travels at 30 kilometers per second around the Sun. Mercury orbits at 47.87 kilometers per second. The challenge is not speeding up, but rather slowing down precisely to match Mercury's orbit." Mission designers planned a gravity-assist ballet involving 6 planetary flybys. Earth once, Venus twice, Mercury 3 times. Each encounter would use a planet's gravity to reshape the spacecraft's trajectory, threading needles millions of kilometers apart. Calloway described the precision required. Each flyby had to be timed within minutes and positioned within a few kilometers after years of flight. Threading a needle from 1,000,000 miles away. Development proceeded rapidly between 1999 and 2004. The Discovery program imposed strict cost discipline. Total mission cost, including development, launch vehicle, and operations, had to remain under $446 million. The team completed spacecraft design and construction in just 36 months, from 1999 to 2002. Testing and integration filled 2003 and early 2004. The original June 2004 launch window was missed due to technical delays, but a backup window in August would prove successful. August 3, 2004, arrived with pre-dawn darkness at Cape Canaveral Air Force Station. Space Launch Complex 17B held the Delta II Heavy 7925H rocket. Sean Solomon watched from mission control as final countdown proceeded. At 06:15:56 UTC, the rocket ignited. 3 solid rocket motors, plus the main engine, generated 1 million pounds of thrust. Messenger climbed into the darkness, beginning its journey to the innermost planet, a perfect start. "57 minutes after liftoff, the spacecraft separated from the third stage. 9 minutes later, solar arrays deployed automatically. 3 hours after launch, ground stations established first contact. All systems reported nominal status. The spacecraft was healthy, power positive, in communication with Earth. The cruise phase had begun. 6.6 years and 7.9 billion kilometers ahead. So much distance to cross, so many precise maneuvers to execute. But time moves differently in space. The first year of cruise passed in careful systems checkout and trajectory refinement. 15 engine burns during cruise phase would fine-tune the complex gravity assist path. On August 2nd, 2005, Messenger returned to Earth. The spacecraft flew past at 2,347 kilometers altitude, using Earth's gravity to redirect toward Venus. Instruments tested during this flyby, imaging the Moon and Earth's magnetosphere. Proof that all systems functioned perfectly. The journey continued inward toward the Sun. October 24th, 2006, brought the first Venus encounter. Messenger approached at 2,992 kilometers altitude. Venus's powerful gravity bent the spacecraft's trajectory, reducing orbital energy to begin matching Mercury's path around the Sun. The thick Venusian atmosphere glowed beneath the spacecraft. Instruments collected data about the planet's magnetic environment. 1 gravity assist complete. 5 more encounters lay ahead over the next 3 years. June 5th, 2007, brought the second Venus flyby, the closest planetary approach of the entire cruise. Messenger swept past at just 338 kilometers altitude. The spacecraft experienced temperatures higher than anything since launch. Thermal systems performed flawlessly, protecting sensitive instruments. The trajectory now curved inward, approaching Mercury's orbital path. The target planet drew closer with each passing month, though years of travel still remained. January 14th, 2008, became a historic date. Messenger approached Mercury for the first time, flying past at 200 kilometers altitude. This was the first spacecraft to visit Mercury in 33 years, since Mariner 10's final flyby on March 16, 1975. During the encounter, cameras captured 1,213 images. 21% of the surface had never been photographed before. Scientists saw new terrain for the first time: ancient craters, mysterious bright spots, and vast plains of unknown origin. The magnetometer detected something extraordinary during that first flyby. Mercury's internally generated magnetic field extended into space, creating a magnetosphere with a distinct tail structure. This confirmed Mercury possesses an active dynamo in its liquid iron core. The core occupies 85% of the planet's radius, compared to Earth's 55%. This massive iron heart explained Mercury's high density: 5.427 grams per cubic centimeter, second only to Earth among all planets. The first flyby had already revolutionized understanding. October 6th, 2008, brought the second Mercury flyby. Again, at 200 kilometers altitude, Messenger swept over different terrain. An additional 30% of previously unseen surface appeared in the images. Combined with Mariner 10's coverage and the first flyby, scientists could now see 95% of Mercury's surface. Strange bright spots noticed in these images would later be identified as hollows, active geological features unique to Mercury. Mysteries accumulated with each flyby, waiting for orbital observations to solve them. September 29th, 2009. Completed the third and final Mercury flyby. This time, the spacecraft passed at 228 kilometers altitude. The primary purpose was gravitational, using Mercury's pull one last time to lower the spacecraft's orbital energy precisely. After this encounter, Messenger's orbit around the Sun closely matched Mercury's path. 18 months of additional orbital refinement would position the spacecraft for the final critical maneuver, orbital insertion. Years of patience approaching culmination. March 18th, 2011, arrived after 6.6 years of travel. Messenger approached Mercury for orbital insertion. At 0045 UTC, the main engine ignited for a 15-minute burn. The spacecraft had to reduce velocity by 0.86 kilometers per second to be captured by Mercury's weak gravity. With radio signals taking 11 minutes to reach Earth, the entire maneuver proceeded autonomously. Mission controllers at APL could only watch telemetry from the past, trusting years of planning. Andrew Calloway managed the mission operations team that night. He later recalled, "We had to trust our calculations and the spacecraft's autonomy." 15 minutes passed in tense silence. Then telemetry confirmed. Engine shut down. Orbit achieved. Spacecraft healthy. Messenger had become the first spacecraft to orbit Mercury. Sean Solomon, watching from mission control, felt relief, joy, and gratitude for everyone who made it happen. The orbital mission could begin. The initial orbit was highly elliptical, taking 12 hours to complete. Periapsis, the closest approach, brought the spacecraft to 200 kilometers altitude. Apoapsis, the farthest point, reached 15,193 kilometers above the surface. This elongated orbit provided different viewing angles: close-up detail during periapsis, global context during apoapsis. Later, the orbit would be modified to 8 hours, then lowered to average altitudes of 100 kilometers for enhanced gravity mapping. Every orbit brought new data, new discoveries, new understanding. Mercury itself defies easy categorization among planets. Its diameter measures 4,879 kilometers, just 38% of Earth's diameter. This makes Mercury smaller than Jupiter's moon Ganymede and Saturn's moon Titan, though more massive due to its high density. The planet's mass is 3.3011 times 10 to the 23rd kilograms. Surface gravity measures 3.7 meters per second squared, 38% of Earth's gravity. An astronaut weighing 70 kilograms on Earth would weigh just 26.6 kilograms on Mercury. The planet's orbital and rotational characteristics create unique conditions. Mercury completes one orbit around the Sun every 87.97 Earth days, at an average distance of 57.9 million kilometers. It rotates once every 58.646 Earth days, exactly 2/3 of its orbital period. This creates a 3-to-2 spin-orbit resonance, a gravitational lock similar to but different from the Moon's tidal locking with Earth. The result is extraordinary. One Mercury solar day, from sunrise to sunrise, equals 176 Earth days, exactly 2 Mercury years. Temperature extremes on Mercury's surface are the most severe in the solar system. At lunar noon, direct sunlight heats the surface to 430 degrees Celsius. During lunar night, with no atmosphere to retain heat, temperatures plunge to negative 180 degrees Celsius. This represents a 610-degree swing between day and night. Yet, in permanently shadowed craters at the poles, temperatures remain below negative 170 degrees Celsius year-round. Cold enough to preserve water ice for billions of years. Mercury travels faster than any other planet. Its orbital velocity of 47.87 kilometers per second makes it the solar system's speed champion. This high speed results from orbiting deep in the Sun's gravitational well. The weak surface gravity, combined with searing daytime temperatures and intense solar wind, prevents Mercury from retaining any significant atmosphere. Instead, it possesses an exosphere, a tenuous envelope of atoms knocked off the surface by micrometeorite impacts and solar radiation. Sodium, potassium, calcium, magnesium drift in this whisper-thin boundary between planet and space. During its 4-year orbital mission, Messenger revolutionized Mercury science. The imaging system captured over 270,000 photographs, achieving 100% surface coverage. Average resolution reached 250 meters per pixel across the entire planet. 16% of the surface was mapped at resolutions better than 50 meters per pixel, revealing details invisible to previous missions. The laser altimeter recorded 10 million elevation measurements, creating Mercury's first global topographic map. Every square kilometer documented, measured, understood. November 29th, 2012, brought one of the mission's most stunning announcements. Scientists confirmed that Mercury's polar regions contain water ice. Permanently shadowed craters at both poles harbor between 100 billion and 1 trillion metric tons of frozen water. Neutron spectrometer measurements detected hydrogen concentrations consistent with thick ice deposits. Reflectivity patterns matched those of icy surfaces. The planet closest to the Sun, subjected to 11 times Earth's solar intensity, holds vast reserves of frozen water in its coldest shadows. Even more remarkably, the ice is overlaid with dark, organic material. Spectroscopic analysis revealed compounds containing carbon-hydrogen bonds. These volatiles, possibly delivered by ancient comets, remain preserved in the polar cold traps. Sean Solomon reflected on this discovery. Who would have thought that the planet closest to the Sun would have ice? It's a reminder that nature is full of surprises. Mercury defied expectations at every turn. The magnetic field mapping revealed extraordinary asymmetry. Mercury's magnetic field is offset northward by 20% of the planet's radius, 484 kilometers from the geometric center. Brian Anderson led the magnetometer team in creating the first three-dimensional map of this offset field. He described the finding as shocking. It tells us Mercury's core dynamics are completely different from Earth's. Surface field strength measures just 1.1% of Earth's magnetic field, 300 to 400 nanotesla at the equator. Yet this weak field is generated by a liquid iron dynamo, proof that Mercury's core remains partially molten billions of years after formation. Another unprecedented discovery was hollows. Bright, irregular, shallow depressions appeared across the surface in impact craters, central peaks, and crater floors. Nancy Chabot led the investigation into these mysterious features. She described them as geologically young, possibly forming right now. The hollows appear to form through sublimation, where subsurface volatiles vaporize and escape, leaving behind collapsed depressions. Mercury remains geologically active today, not the dead world scientists expected. Volcanic history required complete revision. Smooth plains cover 27% of Mercury's surface, an area equivalent to 60% of the continental United States. Gregory Newman processed laser altimetry data showing these plains average 2 kilometers thick. When we saw the full extent of volcanic plains, he explained, we realized Mercury was geologically active far longer than anyone thought. The volcanism occurred between 3.7 and 4 billion years ago, flooding vast regions with lava flows. Mercury experienced large-scale resurfacing comparable to lunar Maria formation. The surface composition presented paradoxes that challenged formation theories. Mercury's crust contains higher sulfur content than any other terrestrial planet, 1.5 to 3% by weight. David Lawrence monitored the gamma-ray spectrometer daily for 4 years, detecting this unexpected sulfur enrichment. Even more surprising, surface rocks contain less than 1% iron by weight, despite the massive metallic core. This iron deficiency is unique among terrestrial planets. Mercury formed differently than Earth, Venus, or Mars. Potassium abundance shocked researchers most of all. Lawrence's instrument detected potassium levels 15 times higher than predicted models allowed. We found potassium along with other volatiles at concentrations that completely changed our understanding of how Mercury formed. Standard theory suggested Mercury formed from high-temperature materials close to the young Sun. Such materials should be depleted in volatiles like potassium, sodium, and sulfur. Instead, Mercury is enriched in these elements, requiring new formation theories. The data demanded revision of decades of planetary science assumptions. Tectonic features told the story of a shrinking world. A global network of compressional scarps called lobate scarps extends across the surface. These cliffs reach 3 kilometers high and 1,000 kilometers long, formed as the crust buckled inward. Analysis indicated Mercury's radius decreased by 7 kilometers, 4.3 miles, as the interior cooled over 4 billion years. The entire planet contracted like a drying fruit, wrinkling its skin into these dramatic scarps. Mercury's history written in its wrinkled face. The Caloris Basin, one of the solar system's largest impact features, received detailed study. Measurements refined its diameter to 1,550 kilometers. The ancient impact that created Caloris was so powerful that shock waves traveled through the planet. On the opposite side of Mercury, the surface shows disrupted terrain called weird terrain, thought to result from converging seismic waves from the Caloris impact. The entire planet rang like a bell from this cataclysmic collision billions of years ago. Evidence of violence preserved in eternal stillness. The mission's primary phase lasted 1 Earth year, March 2011 through March 2012. All primary science objectives were achieved. The spacecraft's excellent health and remaining propellant enabled extensions. The first extension ran March 2012 through March 2013, modifying the orbit for enhanced gravity studies. A second extension from March 2013 through March 2014 began a low-altitude campaign, lowering periapsis from 200 to 100 kilometers. More data flowed to Earth with every orbit. A third extension pushed the mission into unprecedented territory. From March 2014 through April 2015, ultra-low altitude operations brought some orbits to just 25 kilometers above the surface. Brian Anderson's magnetometer team collected field measurements no future mission would likely replicate for decades. The laser altimeter achieved extraordinary resolution. Cameras captured details measured in meters rather than kilometers. On August 6, 2013, a milestone was reached. Every square meter of Mercury's surface had been imaged at least once. By January 2015, the end approached. The helium pressurant tank that maintained propellant flow was nearly depleted. Natural orbital decay began lowering periapsis below 10 kilometers. The mission team recognized the final months had arrived. Rather than letting the spacecraft crash uncontrolled, they planned a carefully managed conclusion. Every remaining day would be devoted to science. The closest Mercury observations ever achieved would come in these final weeks. March 2015 saw periapsis drop below 10 kilometers altitude. The spacecraft skimmed above ancient craters and volcanic plains. Instruments operated continuously, gathering data at unprecedented resolution. Each orbit brought the spacecraft lower as Mercury's gravity gradually pulled it inward. The helium tank pressure continued dropping. The team knew exactly when contact would be lost. when the spacecraft passed behind Mercury during an orbit and never emerged. April 30th, 2015 became Messenger's final day. The mission operations team gathered at APL, joined by scientists from 14 institutions. Sean Solomon addressed the assembled group, reflecting on 11 years from launch to this moment. At 1519 UTC, the spacecraft captured its final image from an altitude of 2.7 kilometers. Resolution reached 1 meter per pixel, the sharpest view ever achieved. Then, Messenger passed behind Mercury for the last time. At 1926 UTC, Messenger impacted Mercury's surface, traveling at 3.91 kilometers per second, 8,750 miles per hour. The impact location was 54.4 degrees north, 210.2 degrees west, in a basin northeast of Shakespeare Basin. The spacecraft created a crater approximately 16 meters or 52 feet in diameter. 14 minutes later, at 1940 UTC, the final radio signal reached Earth, transmitted before impact but delayed by light travel time. Silence followed. The mission had lasted 10 years, 8 months, and 27 days from launch to impact. 4,101 days of operation. During the orbital phase, Messenger completed 4,105 orbits of Mercury. Over 600 peer-reviewed scientific papers would emerge from the data by 2020. Sean Solomon issued a final statement. For the first time in history, we now have real knowledge about the planet Mercury that shows it to be a fascinating world as part of our diverse solar system. The mission team comprised over 200 scientists from institutions across the United States, Europe, and Canada. 50 engineers and scientists at APL maintained 24-hour operations during critical phases. Round-the-clock shifts during flybys and orbit adjustments. When software glitches occurred during cruise, the team developed patches and uploaded them during Venus flybys. When instruments needed calibration, patient adjustments were transmitted across millions of kilometers. A decade of dedication by people who devoted their careers to understanding one small planet. Ralph McNutt, who worked on Voyager before joining Messenger, watched the mission transform understanding. Every orbit gave us new data, he reflected. We discovered that Mercury is nothing like the dead, moon-like world we expected. Nancy Chabot described how working on Messenger changed how she saw the solar system. Mercury went from a footnote to a fascinating world. Andrew Calloway expressed pride in the team's achievement. We got 4 years at Mercury when we planned for 1. The spacecraft and team exceeded every expectation. Mercury continues its endless orbit. 88 days to circle the Sun, 59 days to rotate once, 176 days from sunrise to sunrise. The water ice rests undisturbed in polar shadows. Hollows slowly form as subsurface volatiles escape into the exosphere. The 16-meter crater that holds Messenger will persist for billions of years. The spacecraft rests where it completed its mission, a permanent monument on the innermost planet. Mission complete. Floating peacefully through the memories of discovery. Each orbit a meditation. Sunrise every 88 days. The patient dedication of scientists. Years becoming moments. 10 million laser measurements creating a map. Complete knowledge where mystery once dwelt. $270,000 images. Every square kilometer photographed. Ancient craters preserved. Volcanic plains stretching endlessly. The Calorus Basin holding its secrets. Impact scars 4 billion years old. All documented now. All understood. Water ice in eternal shadow. 1 trillion metric tons frozen in darkness. Organic compounds preserved. The cold keeping ancient deliveries safe. Comets gifted these volatiles billions of years ago. Mercury's poles accepted them, holding them still. The magnetic field offset from center. 484 kilometers northward. Liquid iron core generating protection. Weak but persistent. Mercury's heart still beats, still molten after 4 billion years. Dynamic interior. Active world. Hollows forming even now. Bright depressions appearing. Volatiles sublimating away, leaving collapsed terrain. Mercury changes, slowly but truly changes. Not dead, never dead. Seven instruments measured everything. Cameras, spectrometers, magnetometer, altimeter, each contributing knowledge, each revealing mysteries. 50 kilograms of instruments, worth their weight in discovery. Perfect tools, perfectly used. The thermal challenges overcome. sunshade protecting spacecraft. 300 degrees in shadow, 11 times Earth's solar intensity. Ceramic fabric from industrial furnaces, repurposed for space. Engineering excellence. Quiet triumph. Six planetary flybys. Earth once, Venus twice, Mercury thrice. Threading needles across millions of kilometers. Precision measured in meters. Timing measured in minutes. After years of flight, perfect navigation, perfect execution. The 15-minute burn. No real-time control possible. Trusting autonomy. Trusting calculations. The engine fired. Velocity decreased 0.86 kilometers per second. Orbit achieved. History made. $4,105 orbits. Every 12 hours, then every 8 hours, lowering to 100 kilometers, then to 25. Each orbit bringing data, each orbit bringing understanding. Patient circles, peaceful persistence. Mission extensions granted. 1 year planned, 4 years achieved. Excellence rewarded with time. Time rewarded with discovery. The spacecraft healthy. The team dedicated. Exceeding expectations. Exceeding dreams. Potassium 15 times expected. Sulfur enriching the crust. Iron strangely depleted. High density with low surface iron. Formation theories revised. Understanding deepened. Mercury unique. Mercury extraordinary. The planet shrinking over time. 7 kilometers of radius lost. Interior cooling and contracting. Crust buckling into scarps. 3-kilometer cliffs marking compression, 1,000 kilometers long. Planetary wrinkles, age showing. Sean Solomon's journey complete. From proposal in the 1990s through selection in 1999, development, launch, cruise, orbit. 16 years of dedication, culminating in impact. Gratitude expressed, relief and joy. The team assembled at APL. April 30th, 2015. Watching final telemetry. Sharing memories. Celebrating completion. Mourning conclusion. Mission family. Decade together. "600 scientific papers published. Knowledge flowing from data. PhD theses written. Careers built. Understanding spreading through community. Mercury's secrets revealed to humanity. Mission legacy. Enduring impact." Bepi Colombo will follow. Europe and Japan's mission. Building on Messenger's foundation. Answering questions Messenger raised. 2 spacecraft arriving 2025. Mercury exploration continuing. Messenger showed the way. Others follow. The 16-meter crater waits. Northeast of Shakespeare Basin, holding the spacecraft, holding the mission's end. Micrometeorites will slowly erode it. Solar wind will weather it. But for millions of years, Messenger's mark remains. Mercury orbits in silence, 47.87 kilometers per second. Fastest planet forever racing. Innermost world. Sunrise every 176 days. Eternal rhythm. No one watches now, but we know. know about the water ice. We know about the hollows. We know about the magnetic field, about the volcanism. We know Mercury's density and composition, its shrinking and its history. We know because Messenger showed us. "10 years, 8 months, 27 days. Launch to impact. 7.9 billion kilometers traveled. 6 planetary flybys. 4 years orbiting Mercury. 115 audio clips telling the story. Journey complete. Rest now." The mission achieved perfection. Every objective met. Every instrument successful. Every orbit productive. From dream to reality. From launch to impact. Flawless execution. Human achievement. Close your eyes deeper now. Mercury still orbits. Messenger still rests. Data still flows through networks. Scientists still publish findings. Understanding still grows. Mission immortal. Sleep peaceful. Breathing matches orbital periods. 88 days, 59 days, 176 days. Your breath, the rhythm of planets. Your rest, the peace of space. Drifting, floating. The sunshade still protects, though no power flows. Solar arrays pointed nowhere, batteries long exhausted. But structure remains, form persists, monument endures, memory eternal. "200 scientists remember. 50 operations team members. Thousands of people who contributed. millions who followed the mission, you who listen now, all connected by this achievement. Shared wonder, human family. The ceramic fabric sunshade, industrial furnace material, repurposed from Mercury, surviving 11 times solar intensity. Engineering innovation, human cleverness, simple solution, elegant protection. Delta II rocket. Third stage separation. Solar arrays deploying. First contact. Beginning the journey. August 3rd, 2004. Pre-dawn launch. Perfect start. Gravity assists, stealing velocity, reshaping trajectory, using planetary motion, dancing through inner solar system, celestial mechanics mastered, Newton's laws employed, mathematical beauty, physical precision. Venus at 338 kilometers. Closest approach. Thick atmosphere below. Trajectory bending. Energy decreasing. Path refining. Perfect flyby. Continuing inward. First Mercury images. 21% never before seen. Ancient terrain revealed. Mysteries appearing. Cameras working perfectly. Data flowing homeward. First discoveries. Many more coming. Orbital Insertion Night. March 18th, 2011. Engine burn autonomous. Team watching helplessly. Trusting design. Trusting spacecraft. Success confirmed. Relief flooding. $270,000 images total. 100% coverage. Every square kilometer. Multiple resolutions. Complete photographic record. Mercury, fully documented. Visual legacy. Permanent archive. November 2012 announcement. Water ice confirmed. Neutron spectrometer detecting hydrogen. Radar seeing reflections. Permanently shadowed craters. Holding frozen treasure. Stunning discovery. Beautiful irony. Organic compounds preserved. Carbon-hydrogen bonds. Delivered by ancient comets. Trapped in eternal cold. Building blocks of life. Resting on hottest planet. Nature's surprises. Universe's complexity. Magnetic field mapping complete. Three-dimensional structure. Asymmetry documented. Northward offset measured. Core dynamics revealed. Mercury's heart understood. Dynamo active. Planet alive. hollows being studied still. Bright, irregular depressions. Sublimation continuing. Features forming now. Active geology. Living surface. Mercury changes, ever so slowly. Volcanic plains covering 27%. 2 kilometers thick. 3.7 billion years old. Ancient lava flows, flooding vast regions, resurfacing the world. Fire once reigned, now cooled forever. Lobate scarps crossing the surface. 3 kilometers high. 1,000 kilometers long. Compression features. Planet shrinking. Radius decreasing. 7 kilometers lost. Billions of years. Calorous basin, vast. 1,550 kilometers. Ancient catastrophic impact. Shockwaves through planet. Weird terrain opposite side. Seismic focusing. Mercury rang. Bell-like response. Final image, 2.7 kilometers altitude, 1 meter resolution. Sharpest view ever. April 30th, 1519 UTC. Last photograph. Final science. Then descent. Then impact. 3.91 kilometers per second. 8,750 miles per hour. 16-meter crater. Permanent mark. Northeast of Shakespeare. Coordinates recorded. Mission concluded. Rest earned. $10,000,000 laser measurements. Topographic map complete. Elevation data comprehensive. Terrain understood. Gregory Newman processing. Creating the first map. Mercury's shape precisely known. David Lawrence, checking daily. 4 years of monitoring. Gamma ray spectrometer healthy. Elemental composition flowing. Dedication rewarded. Discovery achieved. Potassium surprise. Theory revised. Nancy Chabot, briefing public. Science communication. Explaining discoveries. Sharing wonder. Mercury from footnote to fascinating world. Perspective changed. Forever altered. Brian Anderson's magnetometer. 8 times per second. Field measurements continuous. Flying 3 kilometers per second. Extraordinary precision. Technical achievement. Data unprecedented. Future unrepeatable. Andrew Calloway, managing operations. 11 years daily. Trajectory corrections. Spacecraft health. Dedicated service. Mission success. Team excellence. Human achievement. Ralph McNutt from Voyager. Experience applied. Thermal challenges overcome. Oven survival. Innovation successful. Design validated. Career spanning decades. Dedication unwavering. Sean Solomon from Carnegie, Principal Investigator. 16 years guiding. Proposal to impact. Leadership steady. Vision realized. Legacy established. Mercury revealed. Applied Physics Laboratory. Johns Hopkins University. Designing, building, operating. Complete mission management. First planetary orbiter, managed by APL. Capability proven. Excellence demonstrated. Discovery Program, Mission 7. July 7th, 1999. Selection Day. Beginning of journey. 446 million budget. Discipline maintained. Cost cap met. Schedule achieved. 36 months development. Rapid construction. Efficient design. Testing thorough. Quality assured. Launch readiness. Engineering compressed. Excellence maintained. .6 years cruise. 7.9 billion kilometers. Patient travel. Trajectory perfect. Flybys executed. Energy adjusted. Navigation precise. Arrival guaranteed. Mercury awaits, always. Innermost world, fastest planet, hottest days, coldest nights, revealed now, understood finally, mystery solved, knowledge gained. Messenger sleeping, crater resting, mission completed, purpose fulfilled, peace earned, rest deserved, sleep now, all complete. Floating in completion, drifting through achievement, rest in success, peace in knowledge. Mercury, known. Messenger sleeps. You sleep. All sleeps. Rest now. Deep peace. Mission complete. Sleep. Mercury orbits. Messenger rests. Forever peaceful. "16-meter crater. Eternal monument. Sleep now." Stars watching. Sun warming. All peaceful. Journey complete. Knowledge gained. Rest earned. floating, drifting, sleeping. Deep rest, perfect peace, sleep. Mercury sleeps. You sleep. All sleeps. Breathe, rest, peace. Sleep, sleep, sleep. Good night. Sleep well. Peace.